Okay, so we are now. Let me get the mic over here. So we are now live with part 24 of the game engine, part 13 of gestures, and as always, we're going to read a bit of the book at the start. So let me put this floppy little wrist rest over here. And move the laptop that I use to view comments back a little bit. And let's grab this book. It is a pretty big book. Okay, let me grab my trusty red pen. And let's go on to a bright page like GitHub as I usually do. And now let's start reading. Okay, section 4.9.2, implementing atomicity. First, let's tackle the problem of making a critical operation atomic, i.e. uninterruptible. Before we waved our hands a bit, said that by wrapping our critical operations in a mutex unlock pair, we can magically transform them into atomic operations. But how does a mutex actually work? One moment. Okay, so section 4.9.2.1. Atomicity or atomicity? No, it's not. That's sounding too much like animosity. Atomicity, I want to say. Atomicity? I'll have to look in a second if I remember. By disabling interrupts. Atomicity by disabling interrupts. To prevent other threads from interrupting our operation, we could try disabling interrupts just prior to performing the operation, making sure to re-enable them after the operation had been completed. That would certainly prevent the kernel from context switching to another thread in the middle of our atomic operation. However, this approach only works on a single core machine using preemptive multitasking. Interrupts are disabled by executing a machine language instruction such as CLI, clear interrupt enable bit, on an Intel x86 architecture. But this kind of instruction only affects the core that executed it. The other cores would continue to run their threads with interrupts, and therefore preemptive multi-threading still enabled, and those threads could still interrupt our operation. So this approach has only limited applicability in the real world. Cameron says yo to you too. Listen so while I bestow upon you some knowledge. 4.9.2.2 Atomic instruction. The term atomic suggests the notion of breaking an operation down into smaller and smaller pieces until we reach a granularity that is indivisible. The idea raises the question, are there any machine language instructions that are naturally atomic? In other words, does the CPU guarantee that some instructions are interruptible? The answer to these questions is yes, but with a few caveats. There are most certainly some machine language instructions that can never be assumed to execute atomically. Other instructions are atomic, but only when operating on certain kinds of data. Some CPUs permit virtually any instruction to be forced to execute atomically by specifying a prefix on the instruction in assembly language. The Intel x86 ISO lock prefix is one example. This is good news for concurrent programmers. In fact, it is the existence of these atomic instructions that permits us to implement atomicity tools such as mutexes and spin locks, which in turn permit us to make large-scale operations atomic. Different CPUs and ISOs provide different sets of atomic instructions governed by different rules, but we can generalize all atomic instructions as falling into two categories: atomic reads and writes, and atomic read modify write RMW instructions. Okay, 4.9.2.3 atomic reads and writes. On most CPUs, we can be reasonably certain that a read or write of a 4-byte aligned 32-bit integer will be atomic. That being said, every processor is different, so it's important to always consult your CPU's ISA documentation before relying on the atomicity of any particular instruction. Some CPUs also support atomic reads and writes of smaller or larger objects, such as single bytes or 64-bit integers, again assuming they are aligned to a multiple of their own size. This is true because on most CPUs, reading and writing and a line integer whose width in bits is equal to or smaller than the width of a register or sometimes the width of a cache line can be performed in a single memory access cycle. Because a CPU performs its operation in lockstep with a discrete clock, a memory cycle can't be interrupted even by another core. As a result, the read and write is effectively atomic. Misaligned reads and writes usually don't have this atomicity property, because this is because in order to read or write a misaligned object, the CPU usually composes two aligned memory accesses. As such, the read or write might be interrupted, and we cannot assume it will be atomic. See section 3.3.7.1 more details on alignment. Section 4.9.2.4 atomic read modify write. Atomic reads and writes aren't enough to implement atomic operations in a general sense. In order to implement a locking mechanism like a mutex, we need to be able to read a variable's contents from memory, perform some operation on that variable, then write the results back to memory, all without being interrupted. All modern CPUs support concurrency by providing at least one atomic read, modify, write RMW instruction. The following sections will have a look at a few different kinds of atomic RMW instructions, each of its pros and cons. All of them can be used to implement a mutex or spin lock. That's it. We've got one page done. Let's get onto the coding. So welcome anyone that is on the stream currently. We are going to be doing some coding now. I was thinking why the keyboard wasn't going any further, so I meant to. I mean, I usually have the wrist rest here anyway. Okay, so Herdingen says hello. Hello back her. Okay, so if we go on Visual Studio, yesterday we was just doing some basic trigonometry on here, some high school stuff. Let me see what happens when we run it. Let me turn the stick on. Yeah, because we've implemented it. Okay, so what I'm gonna do, joystick, no splash state. I'm gonna do clockwise, and for now, I don't know what happened there with the gestures. I dragged it off clearly. I'm going to get the maths stuff done. So first of all, we need to get the if it's x and y. Let's ignore that a second. Let's in here. Yeah, let's do it in here. It's got float x coord, name it something different, equals joystick get axis position. We need to provide the ID first, so joystick ID, then we need to provide it with the axis, underscore x axis. Hope you're doing well, her. How's your private project coming along? I messed that up. There should be a bracket. I was meant to delete the I don't know what I did. I was meant to put a space there, for some reason I deleted. Why? And what we want to do is see out, is there a tan? Yeah, the arc tangent should be the one we want. what was it? The x chord first, was it? Now y over x. Y chord divided by x chord. I don't know how this is gonna look. I can't remember if this is gonna end up spewing out some radians or what. We'll see. So I do have a maths library here as well, GLM I believe. Technically, yeah, there's no pattern that's correct. Let me just put a correct pattern in there. All fine here, thanks. Good stuff. How's life in general? You been a bit quiet recently? Must be busy with stuff. Let me. Probably could do with zooming in a bit. Okay, so let me put 5 days to go. Okay, so see what we. So yeah, that looks like we're getting radians. So max value we're getting 1.56, 3.17. So it'll be 1.57 is the max value we're getting. So we've got to convert that over. Been playing Cyberpunk. How you finding it? I know you're on PC, so your graphics probably look decent. Obviously, I've heard bad stuff that's been happening with PlayStation and the apparent refunds. You enjoying it? What I've read about it is good. I'm still probably gonna wait for the PS5 version. I might get it on PC as well. I know that's pretty big killer on PC now. You know, when you start whacking on that ray tracing. Yeah. I think my 2080 Ti is gonna start showing its age now. I remember how expensive that was when I bought it. They're worth jack now. Can't remember, what is this? My file is CMAF, so it's part of the CMAF library. So it's actually part of, well, you know, guess C++ in a way. I mean, I realistically should put the library here for, you know, just in case. Okay, so C++ A10 radians to all life in Germany is pretty effed up now. Full lockdown starts on Wednesday until January the 10th. Well, it is nice, but it crashes a lot. Is it buggy? Yeah, it is what it is. In the UK, on Wednesday, because we got a tier system, most places are in tier 3, which is the worst tier generally. They are going to be updating stuff potentially on Wednesday. So yeah, my wedding that's on Saturday is kind of food. That's obviously the limit on how many people can have, 15, including bride and groom, so technically 13 guests, and you can't have food as well. Oh yeah, that's an interesting one. X chord is by 0. Let me try running that. I'll have a look in a second. Oh yeah, it's very interesting. Diesel says hello Diesel. Okay, so yeah, what was I looking at? I wanted the degrees version of it. I'm literally just gonna have to do that. And then why did they define pi there if they do it? I don't know, man. I don't know what these guys are on. In reality, that much precision is enough. On what part of the engine are you working? I'm working on the gestures part still. Okay. So go to 90, then you go to minus. Okay, so to the 90-degree quadrants. Yeah, that's fine. And technically 2 positives. Yeah, the gesture implementation. First of all, let's okay, so what we could do, let's make it so yeah, so let me just try and emulate getting a 0 on here. Seems to be very hard to get 0. Let's do it that this is 0, that's 90, that's 180, that's 270, that's 360. Or should I do like a unit circle? It's that way 90, 90, 90, 90. Well, that's anti-clockwise. Have a look at the unit circle. This is definitely an important part of mathematics that they do not teach you at high school. Even at college level, they do not teach you, the unit circle in the UK. Actually, no offense, I don't think even at uni they go that deep into it. Like, this is immensely important. I'm always, referring to the unit circle for stuff. I learned it from a Khan Academy ages ago. Like, they'll probably do some version of that. And it's like, dude, that's useless. Yeah, should I do unit circle implementation? I just feel like that's going to confuse everyone. If I just start 0 there. Yes, the center is 0, 0 technically, but because of this is what I discovered a few parts ago, I don't think you saw it, is one of the reasons the gesture system wasn't working was because of this reset that we had was too low, and the joystick, obviously, this is a pretty old controller, this is from 7 years ago, it's an original day one edition one, the joystick by default, on my left one, I think it was always at a -10 or a +10 value or something, and that way it wasn't. That's the reason it was, not getting reset properly, or getting reset all the time. So that's the thing. So if you just let it go, your joystick probably won't go to 0, 0, and for you to hit 0 is so difficult. But because again, realistically, if I just do left to right, I should hit 0 technically. Because what I know about C++, this should execute before it's passed into it. Because it's not like it's passed in 2 parameters and maybe there's some extra processing potentially going on. Again, I can provide an if statement and alleviate that issue and whack it down to some really small value. And I have not play tested the game yet. Let me set it to download, so give me a second. I'm just gonna close just my screen so I can just go open up Discord. I would like to check it out anyway. I think that would be, cool to check out. What was your Discord name again? Let's type it in. What was your Discord name again? Message me on there. Yeah, okay, I'll check out the newer version. So let me just launch back. Boom, done. Okay, so we will go in here. Okay, so if it's quadrant 1, where I'm pretty sure I'm happy with the values that I'm getting with quadrant 1. So it goes up to 90. Okay, so now if it's quadrant 2, let me check something. So yeah, just link it over Discord. That's cool. And say if x chord is greater than 0, if it's greater than 0, I'm going to invert the x chord. How that will work. Okay, yeah, that gets us a positive value, but we don't want a positive value. We want to continue it on from 90. So if we get the difference, if we do 90 take away this, and add that on to 90. No. Yeah, add it on to 90. Oh, yeah, because we're not taking away 90, are we? No, we're adding on to 180 then. Nah, yeah. I think that makes sense. I need to. I think probably best if I start putting some brackets here. To be fair. Nope, I messed it up there. It's meant to be on here. Again, I don't trust it. I want to make sure I've got my own brackets in there. Yeah. That works for every quadrant except for the last one now. So what I'm going to do is when y is less than, when y is greater than 0, so you'll be in here, if y is greater than 0, and we're going to copy that, but I'm going to do it at 360 instead. I'm going to test that out. So now if we rotate, we should get like about a 0, 90 degrees, 180, 270, boom, done. So we get proper degrees now. All the way around. So this is what's required to get degrees. I will be abstracting this out. That's a pretty useful thing in itself. That probably could just be a function in itself. Let's bear with me. Let's have a quick look at something. Okay, so now that we know what the degrees is of the rotation, we essentially got that. Just want to make sure. I will abstract this out into a function shortly. So now that we got the degrees, what we could do, let me call this function let me abstract this into a function. Trying to think, should we put in the gestures or should we put it somewhere else that we access it, but it is specific for the joystick. Let's whack it into the joystick class then. Yeah, it can be a static method. There's no reason I can't see why this can't be a static method. Okay, so this is going to be static float joystick. No, I'll say axis angle. So obviously this is like the stuff that we've been doing. We built it on top of SFML. This is an SFML function, SFML function, SFML function, SFML function, SFML function, SFML function, and now we've got 3 functions that aren't SFML functions that we are implementing now. So you know, we're extending it, so we're providing the engine with the features that we need. I'm going to change the zoom factor a bit so it's a little easier for me to read and write. Let's just close this a bit. So axis angle, I want to say get, and we're going to need basically going to need this. And we'll just copy that. There'll probably be a lot of similarities here. Get the angle of a joystick axis. Left and no vertical is 0, and it goes clockwise. The axis angle. I remember that feature that her Dingen was telling me about in Visual Assist. Create implementation. Boom. Yeah, what the hell happened there? So right click. Well, this is giving me an error, so there's something wrong here. Press semicolon, that definitely causes a weird bug. Oh, that's interesting. Okay, so if I go to gesture, we're gonna have to make a few changes when we whack this in there. We're gonna have to change this over here. Ooh, so technically we have to do 2 function calls. Now we need the x-axis and the y-axis, so that's angle of a joystick. I'm going to say x-axis. Oh no, I just got a comment. I will check that in a second. And then I'm also going to say if angle if it's equal to 0, then we'll literally say not angle, if x chord is equal to 0, then we're literally going to say, and this cannot be let's not make this a constant as well. I think it's going to confuse, and then this will be equal to 0.001. You know, just something tiny basically. Okay, see out currently doesn't work, blah blah blah, that's fine. Okay, so we got that now. Let's give it a quick run. Let's comment this code out. So we're going to say std colon c out, and we are going to say joystick get axis angle, and we need to pass in the joystick ID. Then we need to pass in the x-axis, which is underscore x-axis, then underscore y-axis, yeah, let's see what we get. This should hopefully still work the same way. Yeah, get joystick angle is right. Yeah, it'd be better if we did that instead of get axis angle. Okay, so that's all good. Let me rename it the way I heard the get joystick angle. I 100% agree. Build it, make sure it still builds. Anyone seen the trailer for Nobody? That's pretty good. Do you like Mr. Odenkirk? No, we don't really need to do that for the left and right joysticks, because if you again, it's been a little while since you watched the stream. So we've got X and Y axis, but that X and Y axis is more for us, because, you know, X we're always gonna, you know, say that's the horizontal one. Y is always, you know, the vertical one, but we actually set my battery's low, the x-axis and y-axis up right here. So if you are on the right analog stick, then you just do U and R. We're gonna have to update that for PlayStation controllers that are mapped using X input, but that's on, you know, the to do, and we'll, you know, get that done when we do the basically the predefined controller inputs. But yeah, so we don't need to do that. So when we pass in X and Y, it automatically knows if it's on the left or right stick. Literally this right here handles all of that. When you say left or right stick, the rest of the joystick or the gesture stuff doesn't have to even worry about it. And there's something similar to in the gestures, to be fair. Yeah, it's right there. Okay, so we'll do some renaming here. Get joystick angle. So we're printing, where is it? Where are we printing it out? In the gesture. That's what we're printing out. We can get rid of this now. What I'm also, I'll leave this here so I can see that I'm working in between that. What I'm also going to do is have an optional parameter which specifies if it's degrees or radians. So by default you'll be, you know, degrees. Constable is degrees equals true. Simple as that. So obviously, because if you set it to false, it's, you know, it's assumption that it is radians now. And let me go to joystick. You've got to get rid of this. So we're basically going to say float multiply factor equals 1.0f, and we're gonna say if one is degrees, then we're literally gonna set the multiply factor equal to this. And now we're just going to put multiply factor here. So that way we can specify if it's degrees or radians, which is, you know, which is useful. Being able to have that distinction, there might come a time that we want radians as well. Okay, let's see what we get. I just want to make sure it's still working. That's really all I want to make sure. We're gonna get an error. We should get an error. We didn't, because it's a default value. We didn't get an error, which is good. Okay, so that's working all good. What we want to do now, I need to actually comment another param, and this is going to be is degrees or radians true for degrees by default and false for radians. Let me just confirm that this works. So if I put in false here, why don't you simply check if it should be degrees or radians at the end of the function and multiply the result or not? No need for the multiplier variable. Okay, I'll have a look at that in a second. Let me see this is working. Sounds like a good. Ooh, yeah, ooh, yeah. So there's a bunch of obviously we're not factoring the fact that we put that in, so we need to do, you mean like here? No. That won't work because the multiply factor is only on this part, not on the part where you take and add in. But we need to change these as well. So we need to say float initial angle 0.0, put it as 0.0. Actually, let's put all zeros as like that. So we're gonna say still don't quite get what you mean. I don't know if you would work with this. Let me know if you think you would. Yes, so here we're just going to have initial angle. Here we're going to do a multiplication by the initial angle. So that way we don't need to do multiple checks. It's just a divisible by 2 and 180. So if we just put in here initial no, that's part of the else, sorry. So this is 180. Remember, it's pi for 180. So yeah, it's pi 3.14159. That should be enough precision, to be fair. 159. Boom, that one works. We need a semicolon there. Let me just run this now. I don't seem to be working well. Yeah, obviously that initial angle. So here we're just gonna, don't need an initial angle there. Well, duh. So we get to about 1 point, yeah, so we should get to about 6.28 roughly. Before it flicks over to 0, obviously it's hard to get this. Yes. Whoa, what bam. Okay, so that works. I know. The thing is, like, when you're doing this game engine stuff, like in this video over the last 40 or so minutes, just being spent doing basic trigonometry, you can easily, obviously this is going to go on a slightly philosophical work ethic rant, but you can easily get disheartened and think, oh, you know, I haven't really done much. So it's like, all I've done is basic trigonometry. You know, this for me is basic stuff, but you know, to implement it in code can take a bit of time, and it's stuff that needs to be done. I might discover that this already has some implementation on there, that is fair enough, that could have saved some time, but like in terms of we need to get this stuff done. build it. Now that we got this, I'm gonna go back to the splash state. I'm gonna set this over to clockwise, and I'm gonna say that it only does any of this stuff if this might need to go into there, but we'll see for now. If what is it? We'll just go gesture pattern. If it doesn't equal clockwise, and let me copy that, and it doesn't equal anti-clockwise as well, let me implement that. Not anti-clockwise, counterclockwise. Well, what was I doing? So now, if I go back to this plastic, if I do clockwise, that shouldn't break now, where it was last time, because the gesture shouldn't be checked, because it's not, because it's clockwise. I guess checked in set X axis. Set reset axis. And where is that method called in? It's called in one of these other methods, isn't it? So by that point we've set the pattern. So we're going to say, we're just going to do the same check here. Copy that. I know there's a message from you here in the comments. Let me just do this and then I'll check it. Yeah, that works fine. I'm going to change this in gestures from that to that, so it's still degrees now. Okay, so what I meant, calculate it in degrees and do the conversion if needed at the end of the function directly on the result, calculating radians and then convert to degree. Maybe not the end, but I think what you might be meaning is like I don't think I'm understanding it properly. You basically grab this part of it out. Let's say angle. How about something like that? I think that's what you may have had in mind. And then I don't actually need this else then, do I? Let me try that. No, okay. I'm producing the right values. What did that mess up? That messed up something enough. They start working. No, actually that's messed it up entirely. That ain't working at all now. So something that I've done in here, I just messed it up. Don't think it's anything to do with this. Yeah, that ain't working at all now. Initial angle needs to be 180. I think that's the issue. It's got a problem with quadrant 1, which is technically... Yeah, I know what the issue is. No, we still need the else, don't we? Do we still need the else? I don't see why that ain't working for quadrant 1 anymore. Well, that's just decided to bugger up. We should be hitting 360. Instead of going back to 0, it's going to negatives. So it's going to negatives. And the x chord should not be a negative there. Angle multiply equals -1. Let's try that. That should fix the issue here. Boom, done. Again, just spending time doing some basic school maths. Oh Jesus. Get rid of the multiply factor. Again, I'm not too sure about that, because again, we still need to, the angle needs to be changed, like this needs to be modified before we do something with the initial angle. But I think I know what you mean. Is do it all in radians, then do it. I think I know what you mean now. I'm gonna copy. I understand what you mean. I'm gonna copy this. Make sure I've got a backup copy. So you mean instead of doing this, this is radians now. If the initial angle we set to 180 is half of that, so 1.570, let's say 8. I think that's what that should get us to, roughly. Pi divided by 2, 1.5708. 570. Yeah, that should get enough precision. Oh, 79. So 57079. 57079. So yeah, that should get us to enough precision. If we gotta do anything with the initial angle, boom, there we go. And then you're saying right here, don't do this multiply factor. I'm not too sure about this. I'm gonna get rid of this in a second. Let me cut this. So you're saying, basically say, if is degrees return. Is this what you meant? Else. I guess technically you don't need the else there, because if you don't hit that, then you'll go to the other one. But I think it looks a little neater. Let me run this, see if this works, and then we'll, you know, sort things out in the thing, because there's a few things that need to be sorted out. Yeah, that's not working. Quadrant 2 and 3 ain't working. I think it's because of this one here. Don't think we actually need this. No, that ain't working anymore. Yeah, what have I done? I've messed something up. So that won't work. Quadrant 2, is it resetting the value? So yeah, it's resetting the value for some reason. So quadrant 2 is x chord is greater than 0. We're doing angle, initial angle, which is 180. That is the same thing as 180. Is it the same thing as 180? Yeah, it is. Minus angle. Is it? Yeah, I'm pretty sure it is. That all seems to work fine now. Let's see if I can grasp why that is working fine, aka now. Oh, sorry, no, that's 180. No, remember, on radians, 2 turns isn't 1 pi, or a whole turn is 1 pi. Pi does half a turn, 180. That makes sense. That makes sense indeed. So what can we get rid of that we do not need? Yeah, so low check. I don't have a problem with that. Anything else we do not need? I think that's looking pretty streamlined now. Thank you for all the help here. Yeah, make sure this is working in regular and degrees. With a degree is working, let's make sure it's working in radians. So we should get to about 6.28. There we go. Okay, so that's working good now. Okie dokie, so don't want to do that. So what we'll do now is I'm going to wrap up the stream. Again, mainly what we're doing is some basic high school trigonometry, but it's important stuff. So let me start implementing this. So gestures, high school trigonometry, trigonometry. And then we'll push to origin. Now you can always get rid of initial angle because it's always pi. What you saying? What you saying? What you saying? Get rid of initial angle. It's always equal to pi. Oh, you mean just put the hard-coded value of pi in there? Or just actually call it pi, maybe? I'm looking at... Pretty sure I did include GLM. Pretty sure that's part of one of the external libraries. I thought I did. I guess that's all that's required now. I can put that. I don't need the multiply factor anymore. Yeah, true. If it is pi, it can technically never be changed. We could have a... Okay, so that's pretty cool. Now let me do another basic commit. Let's call it, oh yeah, the most epic commit names you're gonna see on the web. Also the most useless. Yeah, I removed that multiplier factor. So yeah, thanks for the help here. We streamlined this pretty well now. I think at one point the number of code lines were always double this. Oh yeah. What do you mean? Okay, we got a comment from Juzette. Hi Sona, thanks for the video tutorial on creating tic-tac-toe SFML. Remember when correctly that. With it, I'm writing a team paper right now. If you answer something, I hardly understand you because I am from Russia. Okay, do you have a question? Didn't quite get that. What I would say, because I'm going to be wrapping up the stream shortly, whack it in the Discord group. So let me give you a link to the Discord group. This is, yeah, over 1,100 members now. The next goal is 2,000 members. So do that. So that's the Discord group that you can access to post everything on. So I'm already thinking of how to do that clockwise turning and anti-clockwise turning. So now that we've got angles, we could potentially even refactor that other system that we had with the points. That works pretty well for now, so I'm not going to be touching that. For the angle thing, we could say if the, let's say the stick is this far out, we could use, we would essentially, to do that, we would have to do this again, some more trig. We would need to essentially get this value here. We will need to get the, this one. So basically, a squared. A squared, where are we? Yeah, so a squared plus b squared equals c squared, so we just get the square root of 90 squared plus 50 squared, or whatever the x and y values are. Then we'll get that length, and once we got that length, we can determine how long it is. If it's above, we can figure out what the max is. If it's above a certain amount, we can say, yeah, that's obviously that's up to the developer to decide. That's enough for the turning to be valid, essentially. Then we can just see if the, while it's still greater than that, is the next angle greater or less than the previous one. And we could keep track of all of that. Yeah, I've got a few ideas of how we can do this. This is going to be an interesting one because it's going to be slightly different because it's just a general rotation. So I'm looking forward to this. So once we've done that, then we're going to, part of it we want to detect how many degrees in total we've turned. I think that's going to be much of an issue. Number of full circles turned. Once we got degrees turned, we can calculate that. We just do divide by 360. Integer division for that, and total turning duration as well, if it's, and also if it's turning. Okay, so I think either tomorrow or the day after we should get the gestures done, assuming I don't come up with some other gesture that we need to implement in there. And then we can go on to dead zone in analog sticks and then rumble. So I'm excited to see if we can implement that in our engine before we know it. the info stuff will be done will be on other features. So that is it for this live stream. I want to thank everyone for watching. Obviously we got the Discord group right here, so if anyone has any questions, you can post it right there. There'll be not just me helping out, there'll be other community members as well. I look forward to seeing you tomorrow for the next live stream, where we'll be, if not tomorrow, the day after, we'll be finishing off the gesture system, slowly getting there. I'm getting a bit tired. Did some rudimentary high school maths today and implemented in code, which was pretty useful and pretty cool. So the gestures, we was on part 13 today, we'll get to part 14 or 15, and then we'll move on, and we might potentially come back and we might have future parts as well. So that's it. If you have any questions, feel free to pop me a message, Discord and all other jazz. I look forward to seeing you tomorrow. Have a good day and have a good night.